In this video, I am going to do a related rates problem, and this related rates problem is fairly complex. There are several moving parts in this. You are a manufacturer of widgets. You build 2,000 widgets per day, and you've decided to hire a new employee. This new employee will take a little while to become productive, so you expect them to be able to build, and this is our formula, X new. You expect them to be able to build 250 times the quantity 1 minus e to the negative 0.1 t widgets per day. Now on day 1, I think this is about 25 widgets. On day 2, I think it's about 45. Eventually, when t becomes large, e to the minus a large number is approximately 0. And so you end up with 250 times 1 minus 0. So eventually the employee becomes fully productive and will build about 250 widgets. Now we have a price demand equation, which is estimated at x, which is the demand, equals 6,000 minus 0.15 p squared. And the question we're trying to answer is how fast is the company's revenue changing on day 5? So this is a typical related rates problem. It's a problem where we don't really have enough information at the outset to answer the question. And that's really typical of problem solving in general. In general, we try to solve a problem. We sit down and say, what do we want to know? What do we know? And we realize that in order to answer the question, what do we want to know, we need to know many more things, and then we have to set about trying to find those things. All right, so we are trying to find how fast the company's revenue is changing on day 5. So let's just write that down so we don't forget. So we're going to say t equals 5, and we want to know dr dt, where r is revenue. What else do we know? We know that when t equals 0, x is 2,000. We're producing 2,000. And what else do we know? We know x new, which is the number of widgets the new employee can build, is 250 times 1 minus e to the negative 0.1 t. And we know the price demand equation, so x equals 6,000 minus 0.15 p squared. And that's really all that we know from the statement of the problem. Now, there's some things we know, which would be, for example, revenue. Well, revenue is equal to price times quantity, which means that dr dt is equal to dp dt times x plus p times dx dt. And so dr dt on day 5 is going to be dp dt on day 5 times x on day 5 plus p on day 5 times dx dt on day 5. And so we can ask ourselves, do we know any of this information? And sadly, the answer will be no. So let's write down the new things we'd like to find out. We'd like to find out dp dt, we'd like to find out x, we'd like to find out p, and we'd like to find out dx dt, all of those on day 5. So effectively what we've done is we've taken a related rates problem, defined up here, what is dr dt, and turned it into a slightly different related rates problem, namely, let's find all of this new information on day 5. All right, well, let's see, we've got a p in here, we're looking for a p and we're looking for a dp dt. We have a single equation to do with p, which is x equals 6,000 minus 0.15 p squared, which means if we know x on day 5, then we know p on day 5. Well, let's think about our equation for x. We know that x is equal to We started producing 2,000 widgets, so 2,000 plus X new. On any given day, we're producing 2,000 widgets plus whatever the new employee is producing. Okay, so if we want to know what X is on day 5, we simply have to ask ourselves, how many widgets is the new employee producing on day 5? So X equals 2,000 plus X new, 250 times 1 minus e to the negative 0.1 times 5. So let's get out a calculator. Here's our calculator, and we want to calculate 250 times 1 minus 0.5 negative e to the x. So the new employee can produce 98.37 widgets on day 5. So we end up with X on day 5 is 2,000 plus 98.37, or 2,098.37. So now we know what X is on day 5. All right, we've just decided, well, if I know X on day 5, I know P on day 5. So that would be 2098.37 is equal to 6,000 minus 0.15 p squared. So let's bring the 0.15 p squared to the other side. So 0.15 p squared equals 6,000 minus 2098.37. So P equals the square root of 6,000 minus 2098.37, all divided by 0.15. So let's calculate that. 6,000 minus 2098.37, long parenthesis, divided by 0.15 is 26,010, and we take the square root. Oops. How do I take the square root of this thing? Hopefully this one? That was the cube root. Oh, the square root's on the other side. So let's cube that. Square root's here. 161.28. So P equals 161.28. So we've got X over here. I'll just fill this in. 2098.37. And P is 161.28. And now we need to find dp dt and dx dt. Well, I've just written down an equation for x. X equals 2,000 plus x new. So let's see. That means dx dt equals, derivative of 2,000 is 0, so that's dx new dt. And dx new dt is, let's see, our formula here is 250, x new is 250 times 1 minus e to the minus 0.1 t. So the derivative of that with respect to t is 250 times negative e to the negative 0.1 t times negative 0.1 equals 2 minus signs cancel, so we end up with 250 times 0.1, which is 25, e to the negative 0.1 t. So dx dt is this formula, and of course we want to find dx dt at 5, and so we have to plug it into our calculator. 25 times 0.5 negative e to the x, 15.16. So dx dt is 15.16. So that is the speed of increase for the number of widgets we're building. So that's dx dt, 15.16, and dp dt, of course, now we've got our equation, our price demand equation, so we can find dp dt as, let's see, dx dt equals negative 0.3p times dp dt. So dp dt equals 1 divided by negative 0.3p times dx dt. All right, well, we can plug, we've got all of these values. We've got p and we've got dx dt for day 5. So dp dt for day 5 is 1 divided by 0.3 negative times, oops, not times, divided by p, 161.28, times dx dt, 15.16, or dp dt equals negative 0.31 on day 5. So dp dt equals negative 0.31. So that was a little painful, but basically we said to ourselves, again, remember where we started. We were trying to find dr dt. We wrote down our equation for r. We took its derivative and found that in order to find dr dt, we needed to calculate dp dt, x, p, and dx dt all for day 5. We've now succeeded in calculating all of those values, and that means we can calculate dr dt. So going back to where we started, we calculate dr dt as dp dt, 0.31 negative, times x times 2098.37 plus p, 161.28, times dx dt, 15.16, or 1,794.51. So with a little bit of work here, we've calculated dr dt. Revenues are increasing at $1,794.51 per day on day 5. So that was a related rates problem. It was a relatively involved related rates problem because we had to figure out quite a few things in order to answer the question. But the strategy remains the same as any other related rates problem. What do we want to find out? What do we know? And then create formulas, take derivatives. If it turns out we have enough information, then we can plug the numbers into our formulas. If it turns out we don't, as it did in this case, then we've got to do a little more work, or as in this case, a lot more work, and we will be able to answer the question.